Tonight I'm going to talk about what I'm calling the modern web, and I mean that from a user's experience as well as a developer's experience, so I'll try to refer to that back and forth. And basically I want to talk about how this rich JavaScript ecosystem developed and kind of some of the big milestones along the way, and then I'll show a couple samples of how that used to look and how it looks today. A little bit about me. I work at VMware. I am a user interface engineer on the Clarity design team, and the Clarity design system is a toolkit of UI guidelines and resources, as well as a UI JavaScript HTML component library. And then the really advanced components are actually written in Angular so that you can add data and functionality and really make them work with an Angular app. Internally, they're heavily used throughout VMware's products, so we kind of evolved the project with a focus on the enterprise, and that kind of led us to take a different approach to our design system because we were starting on the desktop and degrading for mobile because most of our customers work on a desktop. So that kind of influenced some of the design choices we made along the way. So a little more about me. I started writing JavaScript, I don't know, around 2004, 2005, and this was back in the day when there wasn't any modern frameworks, there wasn't any one way to do things. And let's see. As I moved through my career, I started working with different people, and when I started up a group out in Westlake Village that just like-minded people that wanted to meet up, I often got questions about why is it so complicated? Actually, sorry, I'm going to back up. I messed up. So tonight we're going to talk about the history and where JavaScript came from. We're going to look at some of the dev tools that have evolved to help the developer experience. And then I'm going to walk through what I call this timer app, which is a simple application that has, some specifications we could talk about, and then show you how it could have been written 10 or 15 years ago in ECMAScript 5 or earlier. Show you how you can turn it into more modern syntax with ES6, and then I'll try to walk through a high level of what that could look like as an Angular application in today's ecosystem. So back when I started really trying to meet like-minded folks and hang out with them, I'd have conversations with some of the people who showed up to the meetup out in Westlake Village, and they'd say things like, why is the web so complicated? Or I'm here, I'm an engineer, but I'm a back-end engineer, and I hate JavaScript. Or has anyone ever heard someone say, I just want to use Jquery in a way that says it's not a good thing to be using Jquery for what they're trying to do. So that's kind of who this is for. People who are new to web development or people who are voluntold to work on the web client. They have a lot to chew off and a lot to understand why things are the way they are. So this will hopefully walk us through how we got to here. We had things that people may be familiar with. There's Backbone.js, Knockout, AngularJS, Angular, React, Vue. We have JavaScript, ES6, Typescript, Babel, Webpack, Gulp, Grunt, and many, many more that I didn't put on the slide. Even more than that. There's so much out there. There's no way any one person can be an expert or even know kind of all the tools. So we got here by a couple different important evolutions in JavaScript, and I think it's important to understand those so that as you are bombarded with new tools every day, you can kind of say, what kind of niche does this fill and where did it come from? What drove the evolution of this tool I'm using? And the way I see it, JavaScript has had a 20-plus year evolution, and it has really 4 or 5 phases or eras, we could call them. In the beginning, it was very simple. HTML, CSS, JavaScript, throw it on a web server, you're good. Then things got a little more complicated. Users wanted a little more functionality in their app. It got a little more difficult for a couple reasons we'll outline in a minute. But jQuery came along and kind of helped solve those problems. It helped really address some developer pain points and made things a little better for the end users of those apps. But jQuery had some problems too. The more it got used, the more pain that developers had using it. And some really smart developers said, we can do better than this. So what I call Frameworks Part 1 came about, and these projects really helped kind of organize code bases, organize teams around concepts and design patterns, and then make it a better developer experience, make apps a little bit closer to a native app, which users are really coming to expect around this time in the evolution. And then I put tooling in between frameworks and the two framework parts, mainly because it needs a home, but it evolves kind of along the same time as the frameworks 1 and 2. There was a lot going on during that time, and so we'll look at some of those tools and kind of how they look in practice. And then we'll end up the history lesson with frameworks part 2. I'll look at 2 of the big heavyweights in the industry today, and then we'll go to a demonstration I have of looking at that timer app 3 different ways. So way back when, where did it begin? In 1989, Tim Berners-Lee created the World Wide Web. He started sharing documents with his friends around the world and making new friends, kind of laying the foundation for what the web could become. And he did it with HTML and CSS. A little bit of information, a little bit of style. It wasn't real pretty by today's standards, but it was leaps and bounds ahead of what anything else was at the time. And that lasted for a couple years, and folks started kind of expecting a little bit more out of their web pages, or products needed to do a little more with their web pages. Collect information, submit forms, other things had to be, people said, what if we could do that? And in a short 2-week burst, I think around 1995 or so, Brendan Eich coded up JavaScript, and here we are today. But it all really started in the evolution of JavaScript, that 2-week period. And it enabled a lot of things, it created a lot of problems, but those problems got solved, and new tools were built to address those problems. So it was actually a really exciting time, even though by today's standards, a 1995 website probably looks pretty arcane right now. So some of the problems that they had were around the issues with standards and the need to do the same functionality for addressing multiple browsers. And that was a big pain point for developers, because they spent all their time coding a feature 5, 8, 10 different ways, depending on how many browsers were out there that they wanted to support. And the browsers weren't cooperating, because there's some nascent standards committees out there, but the browsers didn't implement the standards the same way. So it had a lot of problems for developers, and they solved them, they got through it. But they needed another tool. And around 2005 or so, I think John Resig was his name. He's the initial creator of Jquery. And there were a couple other tools out there at the time that are worth mentioning. My notes are gone. But the tools that I remember are YUI framework, the Moo tools. I think Prototype was another tool that tried to solve these problems in a way that developers didn't have to worry about browsers. They could abstract the layer on top of the code that would work, and then the client delivered to the browser would figure out how to address each browser quirk, as it is probably called. But jQuery did 5 things really well. And it really enabled a massive adoption. And the first thing that it did really well is it exposed something called the jQuery object. And this was a thing that no matter what else jQuery would do for you, it let you extend it. It let you build your own functionality. So when you use jQuery and it solved some of those other problems, but you had a new problem, you could write your own custom solution in jQuery style and plug that into your app without having to worry about the browser quirks, the other things that were going on. The other thing it enabled with plugins is it was really the first time I saw a massive sharing of these tools. People were saying, well, we solved this drop-down menu issue, and now if you want a drop-down menu, you can go to there was a sort of a pseudo repository of jQuery plugins. You could look for something, see who was developing it, and use it in your project, and maybe even contribute back to it in the early days before GitHub. So that was one of the big things that I think helped jQuery become the de facto tool that developers use when they really started looking for some structure and organization in their apps. And then the second thing they did is they standardized DOM access. They made it very simple to find an element and do things to it. And they did it in a way that abstracted above almost all of the browser quirks that were causing developers to not waste time, but spend a lot of time making sure their app was performant and working in a wide variety of browsers. I think that one was really important. Event handlers is a similar pattern to the DOM access. But basically, they provided a standard way to find elements, attach functionality to those elements, and not have to worry about it working in one browser and not another browser. So those standard wars drove a lot of what the fundamentals of jQuery problems that they solved. The fourth thing it did is it baked in simple animations, hide and show, slide up, slide down, etc. If you've ever seen an app that does that, jQuery provided an easy way to do that, and it did two things. It made it easier for developers to add some polish to their apps, and it also kind of started to raise users' expectations for what the web could become. Like, it wasn't just a toy anymore when it looked and behaved a little more like a native app. It was actually kind of cool to work on it. It was kind of cooler to use it, and a little more fun for everyone on both sides of that table. And then the last thing that jQuery really solved, the last problem that it solved, was AJAX. And before you had a standard jQuery library or API, if you will, you had to write AJAX for multiple versions of browsers and identify quirks in one but not in the other, and tailor your application to deal with all that. Well, just by using jQuery, you could abstract above that layer and move on to doing app development, working on what your users wanted. And I think this really drove a large part of the web forward way back in period between like 2005 and 2010-ish, where we got to what I call frameworks part one. And this is where the use of jQuery has proliferated and been adopted at a massive scale. But it started causing some of its own problems. And if you notice a pattern here, I think it's something that software development has always had and may never be able to get away from is, you build a tool that solves a problem you have, and that tool is useful and it gets used a lot, and the massive use of that tool causes more problems, so you build another tool. So these tools that came about kind of in this period were some of the early things that I consider as frameworks. You could call them libraries, collections of utilities. The first one I heard about but never really got deep into using was something called Knockout.js. I believe it was used or came out of Microsoft or a Microsoft-related project, and it pioneered this idea of model view, view model pattern, a design pattern. So anyone who's kind of educated themselves in computer science will know there's all kinds of design patterns that are useful. But before this time, JavaScript really didn't have an easy way to apply those patterns. Some folks did it because they figured out how to do it, but it wasn't shared. It wasn't adopted as a standard way of doing things. So Knockout kind of identified this pattern and then wrote some code that let you create an app with this pattern in mind, and it helped you abstract your app up a level or two, understand here's the pieces of my app, this is the model, this is the view, and the view controller is what kind of glues them together. Fast forward a year or two, and Backbone said, hey, we like what you're doing maybe, but we're going to do it a slightly different way. I don't know if they said that, but you know what I'm saying. It's a new tool that was developed in a similar pattern, And it was the first one that I used in a real production context. But basically, the library gave context and structure to help organize the code base. And they did that by providing these three big building blocks: models, collections, and views. Models obviously is where your data will live. Views is where your data will show up and be presented. And then the collections wires them together, and in between, you get to write what happens and figure out how that behavior works. So that one was the first one I used. And then the second one that I used, starting I think around 2014 or so, was when I first came across Angularjs. Just a quick note, it is now Angularjs and Angular, there's two projects with the similar name, but they're not the same. We'll talk about that in a minute. But Angularjs did a similar thing in that they provided the model view model controller pattern, but they also said, we're going to ship this framework with some opinions. It came out of Google, by the way, and there are some very smart engineers there, and they had strong opinions on how things should be done, how an app should be constructed. So baked into their library is a very opinionated way of writing a router for a web app. Writing an HTTP API that is used throughout the web app. Writing services that glue various controllers in your app together. So they put all that out there, and Angular took off in a very similar way to, I think, how Jquery took off. And that was good. Apps were getting more functional, they were getting more native-like, but developers were still having problems while these apps were being developed. And so we had a wide variety of tooling kind of spring up alongside these frameworks and kind of evolve with these frameworks at the same time. And there's really four I want to highlight here because they all sort of signify significant advances that make the developer experience in the modern web a lot better than it used to be. The first one was circa in 2011. Ryan Dahl was his name, I believe. He coded up this idea of, hey, I want to run JavaScript on a server, and so he released it to the world, and it was this cross-platform JavaScript runtime that you could write JavaScript and run it from your command line on your computer, and that was crazy because before that you needed a web browser to do anything, and this sort of gave a lot of fuel to JavaScript, and after that people started scratching all different kinds of itches to make their lives as developers easier with JavaScript, and they needed somewhere to kind of share and store those utilities they were writing. So right after, or pretty close after Node coming out, NPM launched and eventually was baked into Node, but it didn't start. They started out as separate projects. But basically, it became this command line utility that you could use to search, find, install, manage this exponentially growing group of tools and utilities all written in JavaScript. And I'll show a sample package JSON in a second. But fast forward a couple years, and people were, really solidifying how standards work in JavaScript, and they were moving forward, but browsers were still kind of causing a little problem. They weren't adopting them. They weren't shipping browsers that could consume modern JavaScript constructs. So a really smart fella, Evan Lee maybe was his name. I can't remember his name, but the creator of Babel basically took that idea and said, I want to write modern JavaScript languages. I want to use it in a way that makes sense to me, that makes my code easier to understand, easier to architect, and I want it to run in some of these older browsers that don't understand it. And so he wrote this tool that takes that ES6, ES7, ESNext now, whatever version you want to write, his tool will turn that into something that IE11 can run. And it's a very powerful tool, and what it does is it does this thing called transpiling, which I think I generally use the word compiling, although it's not completely accurate, but it transpiles your source code into something that the browser understands. And away you go. You get, as a developer, you get a better experience using the modern language, but your code still works in the environment that the products live in. And then finally, all these things kind of highlighted the need for this idea of, well, how do we can compile it and create it, but how do we actually optimize it and split it up and get it ready for this modern web as we realize, not all the bits of our JavaScript are needed right away. So how do we figure out how to do that? And Webpack came along after a couple other sort of orchestration tools were used for a few years. And they basically help you package up and optimize your application for delivery to the web. So real quick, this is just a sample NPM package manifest. And I want to highlight 3 things here that I think they're important to me for understanding what NPM is and what it does for you. It lets you organize your dependencies, which turns into a little JavaScript object, and it basically tells you what the name of your dependency is and tells you what version you have in your project. And dependencies are things that are going to get packaged up and used inside your app when it's delivered to the client's browser. It also lets you manage these things called dev dependencies, because as these frameworks were evolving and getting more complicated, files were getting bigger. Webpack and Grunt and Gulp were doing things like, well, let's concatenate all of our JavaScript into one massive file, but now we need to make that file smaller. So there's a bunch of tools that people wrote to help them automate that and do that. And the dev dependencies you install will help along those lines. They'll provide some little effort that helps automate your app building experience. And TypeScript is one of those that I use in the Angular projects I work on. And then scripts was one of the coolest things. I think it was one of the first things I gravitated to in NPM. And basically, with this complications that were added to the build process for an app, you needed a way to not have to remember Babel build command with arguments 1 and 2 and at this file and that file. So the scripts kind of gives you an area where you can customize the developer experience for your app. It gives you the ability to write a shell script if you want, write a node script if you want, and then execute it with a simple npm run my command and do a lot of complicated things without having to remember what's going on except for the first time when you write that script. So that was I think the NPM, besides Jquery, the NPM evolution and adoption was a big milestone in the JavaScript evolution. And finally, we come to frameworks part 2. And there are a couple out there. I'm not going to talk too much about Vue or Elm. There's a couple others, but they're projects that, do you guys use Elm?
No, I do.
Okay, cool. There's a big fan of it on my team. But they're projects that kind of built on what the first generation of frameworks kind of learned. The mistakes they made, they figured out how not to make them, and the good things, they kind of carried them over. So React was the first one I would consider was like the more evolved of the frameworks, and it was kind of came out of Facebook in 2013. Its claim to fame was really they wanted to, well, they had a massive scale for their applications. I don't know, there's 700, 800 million people back in 2013, maybe a billion. And so they had a really large data set that needed to get into their apps and use the data. And they had a couple key principles that I think helped them manage the large changes that were coming down with these massive data consumptions by client apps. And so they pioneered this concept of one-way data binding. If you're familiar with an immutable state, they figured out, hey, it's better if our app knows there's one source of truth, and when that source of truth changes, everybody gets the update at the same time. And the way they did that is by working with something called the virtual DOM, because we all know that it's extremely expensive to query the DOM, dig into the DOM, make changes to the DOM. What they said is, instead of doing that, Let's just take a picture of the DOM. Let's see what it looks like. And then when we know there's changes, let's take another picture that's a very lightweight process, and then we'll see what's different. And then we can narrow in on those small set of changes, zoom into that part of the application, and update it when it needs it. And it helped really kind of increase the performance of apps and helped, I think, consumers kind of become really comfortable with some slick apps that started to approach a native feel. And then Angular 2016. So I mentioned before there's Angularjs and there's Angular. So the first version of Angular, Angularjs today, kind of was, there was a line drawn in the sand, and I think they had some lessons that they learned and they wanted to move forward, but they couldn't move forward with the legacy code base. So it ultimately ended up being a complete rewrite. And so, you know, for developers like me, I resisted jumping into Angular for a while, and then now I'm not even sure why I hesitated or waited, because a lot of the decisions they made were really good from my developer experience. But the couple of things they did that I think are worth highlighting is they wrote it in Typescript. Typescript is a typed language that is a superset of JavaScript, and it compiles down to JavaScript. Even more interesting is that you can, one, you can use it in any framework if you want, but you can target specific versions of ECMAScript. So you can say, I need my code to run in ES3 because we've got this ancient thing running on a kiosk in this little mall. Well, TypeScript will help you do that and give you the tools to write code in a modern way that can run on browsers that may have been around 15, 20 years ago. The other thing they did was they instead of using the immutable pattern, they have this idea of dependency injection, which is, I think, a carryover. The first time I saw it was in Java World, where you annotate your classes with other bits of information so that when you build your app, it knows, hey, this class needs to know about this service. And a service in Angular world is really just something that's a singleton that can act as a single source of truth for an application. And finally, the one thing that I think Angular is kind of doing better than even React, but React has something similar that's making pretty quick strides, is they have this idea of the Angular CLI. So the Angular CLI is a tool that lets you create a new app with one command line process. And it will let you add a component. And what it's doing under the hood is it's writing all this boilerplate out to the file so that you don't have to create a new class. You don't have to tell your app module about that class. Because things have gotten a lot more complicated, this is a tool that helps kind of alleviate some of that complications. So that's what I have for the history lesson. I'm going to jump over to my computer and kind of walk through that timer app, and we'll see how it goes. Good. May I sit? Sorry.
Yeah.
Thank you. All right. All right. So, is that big enough? Can everyone see? If it's too small, let me just shout out and I'll bump it up. So we have here what I'm calling a native timer app, and we're going to look at it in ES5-ish syntax. This is something that I would have written 2000, 2005 maybe earlier. If you look at the structure of the project, you have an index, you have a source. We're going to ignore this. I wasn't sure if I'd have internet access, so I didn't want to uninstall my node modules. You have this idea of assets where I just put an image and a CSS file, but you might have had another folder for images, another folder for styles. If you had a more complicated web page, you might have multiple ones of those. But I think you get the idea that it was pretty simple. It was an easy structure to understand. And in order to run this app, all you had to do was deliver it to a web server, and clients just needed to go to the web URL, and they're good to go. So my timer has some requirements. Let me talk about those real quick. So basically, we need to start the timer. We need to stop the timer. We need to mark times and list them out somewhere. we need to tell the user when the timer is running, and we need to tell the user when they've added a time to their list. And the way I did this in ES5 is, we have a simple HTML document, and we add in our style. We add in our script, which we'll get to in a minute. And in between there, we have an element we call app. And that app has 3 parts. If anyone knows how to get rid of those things in VS Code, let me know, because the things that pop up, I don't...
Probably have to disable an extension.
Okay. I'll have to look, because it's been bugging me for a couple days. But there's 3 sections. There's the timer display where we show the current time. Then there's the buttons that let the user start, stop, mark, do whatever they need to do. And then we have a list for each time that we want to record and make note of. So the way I kind of went back to the early days, at least as far as I could remember them, is I wrote it all in one script. I had to know if it was running, so I gave it a global state. I had to know where my app was, so I used the native web APIs to get the element and get a reference to it. Then I created a function that I could pass an element to, and if you look closely at the code, you'll obviously see there's some room for optimizing it and refactoring it a bit. But when you call this function, it passes an element that is used in a couple different places to add in the time that is the current one for our calculations. And then we have a couple functions that we can use to attach to elements for starting the timer, resetting the timer, marking the timer, resetting the timer. And so that's kind of all encapsulated in a function, and this is probably even more advanced than 95 to 2000 JavaScript was written, but it was worth encapsulating for the purposes of this. But then in order to get that functionality onto my elements, I had to bind those functions to them somehow, and the way we have today is the web API for add event listener. So I can isolate the click events and then add a function that does some stuff. It checks the global state, which we all know is a bad thing, but we use the tools we have. It adds a class list to this app variable that, if you remember, is defined up top, where we know kind of what that reference is to. And finally, it sets an interval that calls this start timer function every 100 milliseconds. And if you remember that timer function, all it's doing is looking at what the current time is, figuring out how much time has passed, and kind of formatting that number a little bit so that we can have a decimal in our user interface. And that was kind of the extent of the early JavaScript projects that I could come across. Is there was a lot of, we want this functionality and we need to do it this way. And so you kind of threw it all into one file. You tried to avoid global state if you could, but you usually had something that couldn't be isolated, and so it ended up in there, and it caused enough problems that JavaScript evolved past that, and Jquery came along. And while I don't have an example with Jquery, I'm going to move right to turning this code into ES syntax, so it's going to look very similar, but it's worth highlighting that that's what drove the React and the Angular's frameworks for today. So if we check out the ES6 app,
what shell is it?
the built-in one for VS Code.
No,
I use the Z shell, and I forget some theme, whatever, something I customized once years ago and forgot about. So now you'll notice I have a similar structure to the ES5 app, but the index is gone. I now have a package JSON that lets me take advantage of what NPM brings into the developer experience. I have this git ignore, just tells my app what not to care about for version control. And there's this Babel RC, which is an object that Babel uses. And this is where I tell Babel, here's what I want to do with this code. And I'm telling them, use this ES 2015 presets. And when you compile the code I'm writing for distribution, include source maps in there. So if I run Babel without doing anything else, it will look for this file and it'll use those pre-configured presets to generate output code. You'll notice there's no assets. Uh-oh. Oh, interesting. I hope I didn't mess it up. I forgot to show the ES5 app running, but don't remind me to show this one running. I'll show it in a minute. And now I'm not sure why that's there. All right. So in our source, we have what you could consider the structure of our application. Everything outside of it is some sort of dependency that we need to build the app and deliver it. So we still have our index. It still looks like the same HTML structure, but we put our assets inside there. We have some images and a style sheet, and then we have an application that with a Saturday afternoon of time to do all these demos, I turned into something that's ES6. So basically the biggest difference here is that I removed the global state from the application and I wrapped it into a single class. And I put as much functionality in that class as possible. And using ES6, I can do a lot of things in the constructor. When someone initializes a new instance of this timer app, we can do a bunch of things ahead of time and say, hey, find this element and give me a reference to it. Find this other element, give me a reference to it. And that instance of the timer can now work isolated by itself in the browser and not worry about stepping on other bits of JavaScript's toes. We still add an event listener and bind them to click handlers. One thing to note is I had to pass in this, which if anyone who's done a lot of JavaScript development, they'll know scoping is a mysterious and dark art, but basically passing that in lets my function run and understand what its state is.
You didn't want to use Lodash?
I try to keep it as minimal as possible. For this demonstration, okay. Just as pure vanilla JavaScript as possible. And then notice that these click handlers are encapsulated inside my class. And they do basically the same thing. They add a class if it's running. They have a check. And they set an interval to calculate the new time. They have a way to stop the timer, remove the interval so that the timer stops, and etc. We can reset the app. We can mark the time. And so then I now have a nice encapsulated bit of code that I can initialize in my global state with a new simple variable and a function call that says, hey, I want a new timer. So to see what this looks like running, I apologize for not showing the ES5. It looks the same though, except for the background image. So if we open up that index.html, if we open it up, we get a nice little app. We have some buttons. We can start our timer. And I broke it. Oh no. Let's go back to the ES5 one. I'll show you running there. Sorry about that. I do not like live coding if it's at all possible. But let's see, git checkout. Actually, yeah. 5 app. All right. So we have a timer. I can start it. I can tell the user it's running. I can mark some laps. When I mark a lap, I let them know, hey, it's running. I can stop the timer. One thing to note is I can still add times, and that's probably a bug. You wouldn't want multiple things of the exact same value in your collection. So I could write a bunch of code to kind of look at that array and figure out, do I put it in or not put it in, or just put everything in there and figure out, we'll only show the unique things. But modern JavaScript gives us things like sets, which we know is a data structure that lets you just put in one unique thing. And if you try to put another thing in, it doesn't even error for you. It just says, thanks, no, and goes on about its way. So I'll show, I use that in the Angular app basically to fix this bug. So that's the app, it resets. And that kind of takes us up to these modern frameworks where there's a bunch of tooling. And so what I'm about to show in the Angular app is going to be a little more complicated. I'll try to hit these high level, what's the global state look like? What's the DOM manipulation for Angular look like? And then what's the event binding? And how would you get this app to production? So if we go back to code, all right, I have this thing called an Angular timer. And so if you haven't worked with Angular before, has anyone worked with Angular here before? All right, so not a whole lot. So I'll try to kind of help you understand how the project is organized. Again, we have a JSON file, and you'll notice that it has a couple scripts. I generated this app with the Angular CLI, so I didn't actually write any of this. It gives me something that I can use to start my application, which has a built-in local development server. So that gives me the ability to do things like write code, save, and it automatically reloads my browser so that by the time I flip over from my editor to the web browser, I already see my code running or not running in the web browser. Linting is basically a way of keeping your code clean to certain preset configurations of like, oh, you should always have a semicolon, or you should always indent 2 spaces, etc. So they bake that into the app generation for the Angular CLI tool. And then E2E is end-to-end testing. They have another framework that is useful for testing Angular applications. There's a bunch of other projects out there that you can kind of dig into if your use cases are different, that have their own sort of use cases and fans for following. But you see here in our dependencies, we have a bunch of Angular stuff. We have this core.js, we have this RxJS, and we have this zone.js. All the Angular stuff is what makes Angular work for me. And the other stuff are things that Angular depends on. If you're not familiar with RxJS, I'd say that's one of the coolest things I've really had to dive into in the last couple years. It's worth learning. If you ever went from Jquery callback hell to, oh my God, promises are awesome, you'll be a fan of observables when you get into them. That's worth noting there. And then all these dev dependencies. This is how we build and ship this app in an optimized way for production. So everything that Angular CLI needs to build my app is installed in my node modules. And then when I run the right command, it packages it all up, it optimizes it, and it gets it ready for me to do something with. So that's the package. The code itself, Angular needs to know a couple things about my app, and I can change them and configure them as I need to, but basically it has a configuration object. The main things to see here is this prefix and schematics. Prefix is something that we'll use, so every component I build in an Angular app will basically be very similar to a web component. So it'll have its own HTML-like signature where I can bracket app-timer, close bracket, and then close that like you would close any other div or section or whatever. But this tells app, when you create new components, prepend this app. So if I want to customize that for my uses, I just change it there. Everything that gets generated gets that prefix. And then schematics is something that I haven't seen anybody else doing this, but it's this idea that I think Angular wants to make it really easy to update and maintain client applications. So the Clarity project that I work on is a UI library. It's a module. It's not an app. And our customers kind of depend on us to keep breaking changes to a minimum or not include them at all unless we're bumping a major version. And this schematics is a tool that lets you work within the Angular ecosystem and say ng add @CLR Angular. And it'll install this tool, the Clarity Angular components. We also have the ability to say, hey, we know this is an Angular application. Instead of you having to go and put our Clarity module into the application, we'll do that for you. We know where it goes. We'll import it. We'll add that. And when you use our components, it's all ready for you to go. You don't have to do that boilerplate configuration yourself. The other really powerful thing that the schematics does for me as a library maintainer is that when I do have breaking changes or deprecations and you install my project with the Angular CLI, I can scan your code base and say, hey, this thing you're using is deprecated in this version, and I can write a custom note for here, look here and see how long it's going to be in the Clarity library. Look, see when we're going to remove it. Even more powerful if it's not too complicated of a change, and we deprecate something and you don't update it, when you install it with the schematics, I can provide a template for, hey, you're using this old thing, turn it into the new thing so that deprecations or removals magically get handled or notified, hey, you're installing a version that this thing no longer exists and your app's going to horribly break, and we want to let you know about it as soon as possible. So that's a very powerful thing that schematics brings to the Angular ecosystem. So real quick, what that looks like is, as I said, Angular is a tree of components. And so you start with a root component. And the way you get that started is kind of glossing over the bootstrapping process is we still have an HTML file, but it gets really simple. You notice there's no styles, there's no scripts. So when we build the app, Angular CLI and Webpack is actually the build tool underneath there. It's configured good enough for 90% of the use cases. If you really need to, you can eject out of the default configuration and customize it, but I don't see the need for my uses. But what I want to say is our app gets started with this custom-like element called AppRoot. And we have a component, and you'll notice we have a selector called AppRoot. So when Angular comes across this element, it knows what it is, it knows what template to apply to it, and it knows what style to go with it. And there's a couple different ways to do it, but the default version of Angular encapsulates all of that CSS in a way that makes style conflicts impossible. So the names that I use for this component in this style sheet couldn't ever conflict with something else somewhere in the web page or the application. You'll notice there's not a whole lot going on here. We just have this AppRoot and this template. So if we look into that template, it'll kind of feel like we're starting to walk into a tree where we have another custom-like element called AppTimer. And that's really the meat of what it took to turn that ES6 code into an Angular app. And I basically had to have 4 components. I had the timer component, and we'll look at the code in a minute. We have the button bar, we have the display, and we have the marked list. So if you remember those basic div elements we had, they basically become first-class citizens of my app. They can have their own encapsulated style, their own encapsulated functionality, and the tools that Angular provides gives me the ability to manage global state with basically, in an Angular app, you don't really need global state. You can encapsulate all that state inside the Typescript files and kind of work confidently inside there. So for something like DOM manipulation, if we look at the timer display, which is the big number of what the current time is, you'll see, we'll start with a template this time. And this could have been inlined into the TypeScript code, but I apologize, I was a little too lazy to do that. But for smaller templates, generally 5 to 10 lines or less, I'll inline them into the TypeScript file itself. Anything that gets bigger, it's worth kind of separating it out. It gets too complicated. And there's 2 things going on here. We'll come back to time format. But basically, in my timer display component class, there's a variable called current time. And whatever that current time is, it will get interpolated in this template with that value. The other thing Angular will do for me is it will pass that value to this time format function, which I'll show you real quick and kind of explain at a high level what it is and what it does for me. So then we have the component itself, and you'll see it follows a similar pattern. We have, we import the stuff we need from Angular. We import our timer service, which we'll talk about in a minute. And then we decorate our component with these, this metadata for what selector is used, what template is used with this class, and what style goes along with it. And Angular does the work of packaging that all up, encapsulating it, and delivers it to your browser. And our class looks pretty simple. Remember, we have that current time property, and we have two things going on here. We'll come back to the timer service. Remember how I said, DOM manipulation and data binding and things that Jquery kind of brought to the table? Well, Angular has this idea of decorators, and so the at component is a decorator. At host binding is a decorator because Angular views this class as the host. Anything that lives inside there in terms of an HTML template is a child of the host. It's a view, it's part of the view for that host. And so when I use the at host binding decorator, Angular knows, hey, when this thing is true, add the class timer display to this host. So in my browser, I'll have this app timer display element, and it'll have class equals timer display. And now I can target CSS for that host and write things that I want it to do. The other thing that's going on here is, remember how we talked about not having global state, but we still need to maintain state for our app and pass it around. So Angular uses that RxJS project, and it basically gives me the ability to create a stream of time events. And if you're familiar with RxJS, it's basically what I'm doing is subscribing to an observable that basically passes every new time to whoever subscribes to it. So in this case, I subscribe to new times, and whenever they're generated, I hear about them. And whenever I hear about them, I run this Lambda function inline that sets the new time value to this.current time, and we show up in our browser.
Is this similar to the idea of having connected components to like a Redux state, for example?
It's similar. It's not Redux, though. It's not one-way flow.
Like, same idea of having components be listening to a global state.
It's components listening to a state, but I could give a whole 20, 30 minutes in how the Angular providers are organized. At a high level, these providers are a tree. So Angular gives you this thing called an injector, and you can put providers in there. So if you put it high enough up the tree, your provider is available to the entire app. But if I say, hey, I want to define my provider at a lower level, at this component level, then you'll notice, where is that? If we go back to highlight that, if you look at my timer component, you notice that I decorated my metadata with this timer service. So I only inject it into this timer component. But when I want to use it in my, timer display, I don't have to provide it again, because if I did that, I'd end up with two instances. Angular would say, oh, you want one here and you want one here. So it instantiate two different providers, and they're two different states. So by injecting it up top and then putting it into the constructor, Angular knows about it. It knows what type it is. It gives me access to it, and then lets me subscribe to that single state. So does that answer your question? It's kind of multi-layered. You can do global, or you can target it, that state where you want to target it. And then observables work the way observables work. So it's different than that.
On the very first one, you wrote the original one on the ES5. What event did you use to trigger the count?
So I set
Change event? I didn't see it.
just a click.
But you kept on counting down.
Right, so I set an interval.
Oh.
And so every 100 milliseconds, it called that function, and then when I stop it, I basically wipe the interval out, and it stops.
And where does that thing go in here?
We can look at that. So my service is a little messy. It needs some cleaning up. But basically, this starts getting into what is RxJS and how does it work. But we have the subjects, which is the single source of truth. And then I give access to those subjects, subjects with this public getTime method. It returns something with a type observable, and basically it returns that time stream as observable. So whoever subscribes to that will hear about changes on the time stream behavior subject. The difference between a behavior subject and a subject is that a subject initializes and that's it. A behavior subject takes a value and initializes with that value. So if someone's subscribed to it, when they subscribe to it, they get that first value. So basically I want to populate 0.00 as my first timer value. The way I add changes to it is where do I do that? So when you start the timer, if we're running the time calculation, we tell some people that we're running. So whoever subscribes to this running behavior subject will get the next event in that stream. And then for the time calculation, I set this interval, same principle as before, and I calculate the next time, and then I update this. This is the way that people hear about the message that I'm sending. When I get the next time, I add it to this timestream.next function, and so no matter how many subscribers there are to this property, they all get the same time from that observable. Does that help?
This got to be more delay with this one than the other.
Yeah, so it's not a perfect timer.
Okay,
Yeah. There's delay, but it's pretty reliable in terms of propagating out without.
Do it consistently.
Yeah, no, it's very consistent.
As long as that happens.
Yeah.
So just be off by a fraction, but at that point it counts as consistent.
Right. All right, so what are we looking at? So a little more DOM manipulation. And if we get too late, I can wrap it up. But if you're good, I can keep going. Okay. So we talked a little about the timer display. Let's talk about event binding. So we have our buttons. And it's just we kind of took out that little bit of functionality from the ES6 app. And now we need to bind some functionality to our user interface. And we don't want to use add event listener. So Angular gives you this convention of tying into the native browser events. So as you'll see here, click is a native browser event. And by putting parentheses around it, this tells Angular, hey, listen to the click event for this element. And when it hears something, run this function, which is defined in my Typescript class. And so it works for mouse over, mouse move, any event that's a native one you can use. And you can write your own custom events that kind of notify, hey, something happened. So there's a lot of flexibility in using what's already there, but kind of customizing it for your needs later. If we look at the Typescript class, you'll see, there's the metadata for the decorator. We inject our service, but we don't do anything in the constructor. What we do is we use those bound functions to tell the timer, hey, start the timer. Hey, timer service, stop the timer. So we can very nicely kind of break out the pieces that need access to that timer service, that global state, and keep our component class as focused on what its job is. And the only job of the timer bar is to start, stop, mark, and reset. And then that's event binding. We'll talk about, I think the last thing to really talk about is how would I get this to production? But before we do that, let's just show it running so you can kind of see that I do have a functional application. So remember the package JSON, it gave me that and that list of commands. They basically run the CLI, which tells it, hey, they want to serve this app. So it goes and looks at everything I've configured. It finds all my files. It stuffs them all together. And it starts a dev server for me. And I can see a running Angular app that is a timer, you'll notice it works pretty similarly to the other ones. We can mark times for our laps. We can stop times. You'll notice I can't add more than one number of the same time, and basically I used a JavaScript set, which does all the work of keeping values unique for my use case. So I don't have to write extra. The nice thing for me is that modern construct means I don't have to write extra error handling code. I don't have to worry about that if I kind of pick the right tool for the job I'm trying to do. And that's it. So that's the developer's experience. But
Storing the actual time for the lap, did you just do a push array?
I push to the set.
Did a push array, okay.
Well, I think when it compiles down, it's an array, but it's got a lot of, it does all the deduping and uniquing of the values so that my array only ends up with the right values. So you're familiar with the concept of a set?
No, but we're just adding one more array.
Right, adding an item to the set, and then it notifies, hey, there's a new item, and the user interface populates. I can go into, oh no, what did I do?
Alright, for the screen, just pull.
Okay, sorry.
Alright,
All right, so here's that marked list component, and it's the consumer of that set. So I already know I'm getting unique values. And basically, I subscribe to that stream, and I update my timer list whenever I hear a new thing on that stream. The way I get it into the user interface is the template actually does change from the ES5, ES6 one. Basically, Angular gives us this idea of iterators. So any templating language you're familiar with has had something similar. But there's this idea of a structural directive. And what that means in Angular world is that anything with an asterisk is a directive on an element. And that tells Angular it's going to actually modify. It's going to create and destroy elements at some point in an Angular application lifecycle. You can have directives that don't do that. They just add behavior. But because we're going to actually conditionally create a list depending on how many elements are in our time array, I know I need a structural directive, and Angular gives us this ng4. So for every time in my timer list, it will stamp out a list item for me, and then I'm good. I don't have to do anything else. The last thing I forgot to show too is this formatting. Remember how I was formatting all the time strings based on the function it was running? Well, that's kind of not reusable or sustainable. If I want to change that format, I've got to change it in a bunch of places. Angular gives this idea of pipes. And so a pipe is something that I can put into my HTML, and then it's a function that basically receives the information. So whatever's mapped to current time gets passed to this function. I write my formatting here, and I reuse it in my HTML wherever I need to. And when I want to update my format, I update here in one place, and everybody gets it. So the last thing I have to show here is production. So the Webpack app, the ES5 app was easy to get into production. The Webpack app would need some, the ES6 app would need some Webpack. You'd have to configure it and get it ready to, concat and minify and optimize assets. Angular CLI gives me a tool, build, and if I give it this command prod while it's running, what prod does is it does all those optimizations, but it also, if you're familiar with how Webpack is really revolutionizing something that we're calling tree shaking. So Angular at build time analyzes my app and looks at stuff to make sure it's used. If there's something in there that's not used, it removes it from the bundle that gets shipped for production, thus making my file smaller, my app a little more performant, my user a little happier. Developers are happy too, because if you're using the CLI, they've configured Webpack for all that, and you just have to type the right flag and you're off and going. So that's all I have for the demo. Let's see here. So that's it. I think we kind of went through these 3 stages. We looked at where ECMAScript sort of pushed the evolution of JavaScript, ES3, ES4, ES5. It was a wild, wild west back then. And there was a lot of issues that tooling and Jquery, ES6 came along and helped address. And then finally, the idea of a framework or a library to work cohesively, to use modern design patterns, to bring that all together, they have addressed a lot of those needs. There's a variety of them out there. I think they're all worth kind of knowing a little bit about, because you never know what's going to be the next jQuery, Angularjs, Angular, or React, which are all, React is massively adopted. I have one more thing. But I do think it's worth kind of understanding those at a high level, no matter what you're using in your day-to-day. So if you're interested in the apps, they are up on GitHub in a repository. Feel free to take a look. I hope this was useful. I hope it took you maybe down to some fond memories or not so fond memories, but this was sort of my journey through JavaScript as I understand it, and that's all I have.